Alrighty, welcome to using pronumerals in place of numbers. So second lesson for today, I believe, if you are following along at home on the appropriate times, because it is our big double today. So using pronumerals in place of numbers. So procedures in this section are more demanding and sustained than in the previous sections, and the whole section may be regarded as extension. Yes, this is your first actual look at proper extension stuff, not just tacked onto the end of exercises. So this whole exercise is basically stuff that we've done, but using pronumerals and terms instead of just plain numbers. All the procedures are exactly the same, just with letters as well. So don't feel like this is overwhelming. This is actually really easy. You're just doing the exact same things, but with letters. And I know you guys are very comfortable with stuff in numbers. So we'll start off with an example with numbers, and we'll see how that relates to doing the exact same thing with some letters. So a triangle has vertices at A, 1, negative 3, B, 3, 3, and C, negative 3, 1. Find the coordinates of the midpoint P of AB and the midpoint Q of BC. So first, what are we going to do? Now, if your answer was draw a picture, well done. Gold star for you. You can see me next term and I'll get you a chocolate. And if you hold me to that, I'm going to be mad, but also slightly impressed. 3, 3. And negative 3, 1. So here. So this looks like this. Now this example has been taken straight from the text because it is actually quite hard to come up with examples like this. So it looks something like this. Now our first part says we want to find the midpoint P between A and B. So here's A and B, so our midpoint's going to be somewhere like here. And our midpoint of Q, our midpoint Q of BC, so it's halfway between these two, so we're going to put a point here. Okay, and so here is our point along there. Okay. Oh, that's actually like a secret. No, never mind. All right. So what we need to do for our midpoint, so midpoint of AB is equal to, now we know it's x2 plus x1 over 2. And whoopsies. Knew I was doing that wrong as soon as I started. y2 plus y1 over 2. Okay, and then for our midpoint for CD, we're going to be doing the same thing. x2 plus x1 over 2. y2 plus y1 over 2. Okay. So going down, we are getting our values in. So our midpoint from A to B, so this one and this one. Okay, I'm not going to label them because we should be past that point now. 3 plus 1 over 2 and 3 minus 3 over 2. So our midpoint is 4 over 2 and 0 over 2, which is equal to 2, 0. Awesome. So, I mean, it's not obvious from that picture, my horrible drawing, but partly because I have done... No, anyway, that's what it is. So, oh, well, it's pretty close. Like, it's just not exact. So it's like here. Yeah, that's better. Anyway. Now, midpoint for CD, it should be CB, not CD, CB, is equal to... Okay, so x2 plus x1, so in this case it's going to be minus 3 plus 3 over 2, and so that one again is going to be 0. And our other one, y2, so 1 plus 3 over 2, and that one is equal to 2. Okay, look at that, it's just the reverse of that, so that's the midpoint of CD is equal to 0, 2. And so if I do that one, that is, again, pretty close. Like, I'm pretty much spot on, except just that little bit off. So, you know, in other words, not spot on. Okay, so there's the two midpoints. Now what we're going to do is show that PQ is parallel to AC. So here's P, here's Q, and we're going to show that those two are parallel. Okay, and then we're also going to show, so once we show that they're parallel, we're going to also show that PQ, so this one here, is actually half the size of AC, or in other words, AC is double the size of PQ. And so I just want to add to, when you are reading these, you read them literally. P PQ is equal to half, remember what times means, of AC. Okay, that's literally what it means. PQ is equal to half of AC. PQ is equal to half of AC. So what we need to do is show that distance is actually, or this distance is actually half of that distance. Okay, so we'll do that in a moment. So first we're going to show that the parallel. So to show that parallel, we look for the gradients. Now to find the gradients when we're given 2 points, then we just use the gradient formula. So M of PQ. So notice it's not MP of PQ this time, it's just M of PQ, is equal to, so the midpoint, or the, sorry, I can't even say it, the gradient of PQ is y2 minus y1 over x2 minus x1. So using that one, we're going to get, so our midpoint is 2, and 2. So it doesn't matter which way I do it. So I'll go 2 minus 0 over 0 minus 2. And so that gives us 2 over negative 2. So that means that the gradient of PQ is equal to negative 1. Now I should actually put a and a B. Okay, so let's finish these up. Midpoint of AB is 2, 0, and BC, I did CD again up there, is 0, 2. Okay, so we found the gradient of that one. Let's find the gradient of the other one, so that is of AC. So we're going to y2 minus y1 over x2 minus x1 again, okay? So my 2 points in this case are 1, negative 3, and negative 3, 1. Okay, so do the first one first. So y minus positive 3 over minus 3 minus 1. That gives me 4 over negative 4. So my gradient of AC is equal to negative, not that, negative 1. Okay, so that's that one done. Now the last bit of this question is to show that the distance between the two is the distance of P to Q. So I'm just going to rewrite it down here. 2, 0, and Q is 0, 2. So the difference between the two, or distance between the two, is half of the other. Okay, so let's do distance 1 is equal to the square root of, we'll do the hard one first. So we go 1 plus, the difference between the two, 1 minus negative 3, all squared, plus negative 3 plus 1, all squared. Okay, so that's going to give me, so 1 minus 3 is equal to 4, so 4 squared is 16, plus minus 3, that should be a minus, not a plus. What is wrong with me? Because distance is the difference between the two. Minus 3 minus 1 is equal to 4. 4 squared is also equal to 16. So the distance of that first one is equal to the square root of 32. Now we're going to turn this into third form, or it is a third. Let's simplify it a bit so that we can make it a bit easier for us to look at. Well, we've got 2 16s, so this is the same as the square root of 2 times the square root of 16. So that means the first distance is equal to 4 lots of root 2. Now, hopefully, to have double, so that one should be double. So for our other one, we should have half of that. So hopefully we'll have 2 root 2. So distance 2, okay, so distance 2 in this case is going to be equal to the square root of, okay, so for this one, we're using these P and Q points up here. Siri just attacked me for some reason. And we're going to go, so 0 minus 2 squared plus 2 minus 0 squared. Okay, so remember in the distance formula is equal to, well, it's d squared is equal to, but the difference in the 2 plus the difference in the y's squared, or it's just Pythagoras. Okay, so d2 is equal to 0 minus 2 is negative 2. Negative 2 squared is 4. 4 plus 2 minus 0 is 2, all squared is 4. So D2 gives us the square root of 8. But that's just like having square root of 2 times the square root of 4. So D2 should be equal to 2 root 2. So now we've got to check whether or not the other one is double of it. So we're checking that PQ is half of AC. So PQ needs to be equal to half of AC. So PQ in this case is equal to 4 root 2. So 4 root 2, other way around. So PQ is equal to 2 root 2. So 2 root 2 needs to be equal to half of 4 root 2. Okay, half of 4 is just 2. So 2 root 2 is equal to 2 root 2 as required. So therefore, PQ is half of AC. It's a lot working out for that question. And we haven't even actually started the extension bit. The extension bit is to repeat the procedure for a triangle with 4A, 0, 4B, 4C, and 0, 0. So what I'm going to do is I'm going to do that underneath. That's actually not part B, is it? That's just part I. And this is part A, I. So first things first, I'm going to, should I do it on the side? Yeah, I'll do it on the side so that we can sort of see it next to each other. And I'll make the space very obvious in this one. Okay. So, I'm going to write the points over here, so I don't have to come back. 4A, 0, 4B, 4C, and C is 0, 0. Okay, so first things first, yes, you've guessed it, we're going to draw a picture. Okay, so here's my axis of symmetry. All right, axis of symmetry, what am I saying? Here's my Cartesian plane. Okay, so A is 4A. So if, let's say A is here, then 4A is just 4 lots bigger. If A is here, then A is just 4 lots bigger. It doesn't really matter where we put this point, okay? We just know it's 4 times bigger than some value. So let's say it's here. So here's A at 4A, 0. Okay, we know it's on the x-axis because the y is equal to 0. We know where C is. C is on the origin, so that's nice and easy. And B is 4B, 4C. We don't know what that is. It's going to be somewhere here, okay? Like somewhere in this region, probably. So let's say it's here, just for the sakes of things. So 4B, 4C, which is B. Okay, so it's going to make some triangle in some form of case, okay? So find the coordinates of the midpoint of AB and BC. So we need to find the coordinates of the midpoint between there and between there. So just looking at this, it's going to be somewhere here and somewhere there. Okay, so the midpoint, so this is A, this is B. And this is part I. So the midpoint of AB, in this case, is equal to, so let's just use the points. It's going to be the sum of the x over 2, comma, the sum of the y parts over 2. So simplifying this down, we get 4a plus 4b over 2, so common factor of 2 on the top, so we can divide the top and bottom by 2, left with 4, not 4, so 4a divided by 2 is 2a, plus 4b divided by 2 is 2b. Okay, so that's the halfway point here, so, you know, what's halfway between 0 and 4b? Well, it's just 2b, and halfway between 4a and 4b is 4c. So 0 plus 4c is just 4c. 4c divided by 2 is 2c. Okay, so there's my midpoint of AB. Now my midpoint for BC is going to be this, almost the same thing. So 4b plus 0 over 2, comma, excuse me, 4c plus 0 over 2, just like that. Okay, so 4b plus 0 is just 4b, divided by 2 is just 2b. And 4c plus 0 is just 4c, divided by 2 again is just 2c. And so does my midpoint. So my midpoint of AB is, so this is 2a plus 2b, comma, 2c, and this point here is 2b, comma, 2c. Okay, and so if we have a look, the x values are the same. So the y values are the same. So that means that these both have to be the same height up. Okay, along here, because they both have to be at 2c. It's just that the difference between them, if you have a look, well, if this one's at 2b, which is half of the distance from 4b here, so here's 4b, so 2b is here, and then this one is just a, or 2a plus 2b. So this is an extra 2a, okay? Plus the 2b on top. So it's like, you know, here plus that little quarter bit, which makes that extra bit. Anyway, so those are the two midpoints. What do I need to do with the midpoints? I need to show that PQ. So this here is parallel to this. So they should have a gradient of 0, correct? And that the that CA is double the size of PQ, or that PQ is half of AC. So let's start off with the gradients. So this is part 2. So M of AC is equal to, so it's a difference in the X, difference in the Y's over difference in the X. So difference in the Y's is what, 0 minus 0. Okay, so 0 minus 0, 0. And the difference in the Y's, well, it doesn't really matter because my gradient's going to be 0, but it's 4a minus 0. Okay, 0 minus 0 is 0. 0 divided by 4a, well, that's just 0. So M of AC, so the gradient of AC is equal to 0. Now the gradient of PQ is equal to, okay, so P is the 2C, okay, minus, and Q's is 2C, so the Y values are both the same. Over, now the X value of P is 2A plus 2B, minus the Y value of Q, which is 2B. Okay, it doesn't matter what's on the bottom because 2C minus 2C is 0 on the top. Actually leaves me a 2A on the bottom, but that leaves me with 0. So M of PQ is equal to 0. So my gradient of PQ is equal to 0. My gradient of MAC is equal to 0. Therefore, AC is parallel to PQ. Okay, but we're not done. We also need to show the distances. Okay, the distance, well, is half of the other one. So let's say distance 1, we're going to use our A values. So just to rewrite them down here, AC. So A is 4A and 0. And C is 0 and 0. And the midpoint of AB, which is QP. So P is 2A plus 2B. Oop, comma, not the bracket. So 2A plus 2B, comma, 2C, and Q is equal to, I think that was 2B plus 2C. Okay, so doing the distance, we'll do the distance of, and I'll call it AC in this one. So that's the square root of, let's move it down a little bit. So the distance of AC is equal to the square root of. Okay, so it's the difference in the x's of A and C. So we'll start with A and we'll go 4A. That's not my A value, is it? Yeah, it is. Oh, A and C. 4A minus 0 squared plus 0 minus 0. So the difference into the two Y values of A and C. Okay, so D, distance of AC is equal to, well, 4A squared is just 16A squared, okay? Plus 0, which is just 0, so D of AC, well, that's the same as having the square root of 16 times the square root of A squared. Square root of 16 is just 4, A squared square root is just A. So my distance of AC is just 4A, and we know that too, because the distance from 0, 0 to 4A, 0 is just 4A. So this distance down here is just 4A. And we've shown that algebraically using my distance formula. Okay. Now, let's do the distance of PQ. So D of PQ is equal to the square root of. Now this one's going to be a little bit trickier. So it's going to be the difference of the x's. So we've got 2a plus 2b minus 2b all squared plus 2c minus 2c. Okay? And we know that's going to be the case for the y's too, because the difference between the two y's, well, it's just 0 because they're on the same horizontal line. So d of PQ is equal to the square root of. Okay, so we'll do this first bit first. 2a plus 2b minus 2b. Okay, well, that's just, that cancels with that. Well, I can leave that there because you guys are quite intelligent and will know what that means. So we've got 2a squared. That just cancels with that, so we get left with plus 0. So the distance of PQ is equal to, so we've got the square root of 4a squared, but we know that this is the same as the square root of 4 times the square root of a squared. You know the square root of 4 is equal to 2, so d of PQ. You know the square root of 4 is equal to 2, and we know that the square root of a squared is just equal to a, so we get dp of PQ is equal to a. So does this satisfy our definition? Well, our definition is that PQ is equal to half of AC. So PQ needs to be equal to half of AC. We know that PQ is equal to 2A, little a, not big A, so 2A, and that's equal to half of AC, which we know is equal to 4A. Okay, so 2A is equal to 2A as required. Okay, so therefore PQ is half of AC. Now that was a lot of working out just to that one question, okay? You guys won't be talking through yourself through it though. Well, you know, you might be, but you can actually do it in your head as you're doing it. But that's pretty much how we are going to tackle problems like that in this topic, okay? So it's literally what you've done, but it's just using pronumerals and it's using your algebraic skills to solve the problems, okay? And in fact, this gives you a general form for whenever you've got, you know, 4 lots of one number plus 4 lots of 2 other numbers in your B, you know, and stuff like that. Anyhow, with that being said, that is completed, and I hope this helps you a lot. Make sure you do email me too. My email address is on the Google Classroom if you need that extra assistance. I can make videos specifically tailored for you to help you with certain problems, just like I'm doing on here. Okay, so don't feel like that, you know, it's a hindrance. Remember, this is my job, and I am here to help you guys through this. But with that being said, I hope this helps.